Let's look at maybe question number 6. Oh, I'm sorry, maybe 11 in this video. Question 11. 11. Hey, this is short. That's good. I'll do this. All right. It says, answer the question for the function f of x equals x to the 4th power minus 4x to the 3rd power. They say find the formula for the first derivative, f prime, and the second derivative, f double prime. Oh, that's easy. We got this. So the first derivative is 4x to the 3rd power minus 12x squared, just using the power rule. And going to the second derivative, 4 times 3 will give me 12x to the, and I have to go down 1 from the degree of 3 squared minus 12 times 2 is 24, and x squared becomes just x to the 1st power. Okay, I'm going to zoom out. Can't be that easy, right? I'm probably sure it's going to give us more parts to this. Okay, check the answer. Okay, what are they going to give us? Oh my gosh, this is 7-part problem. All right. Set f, they said set the first derivative equal to 0 to find critical numbers. One of the critical value of f of x is x equals 0. What is the other critical number? How nice of them to give us the critical value. Okay, we'll find the other one for them. I may not be able to finish the entire 7 parts. I can see I have 7% left on my laptop. Maybe I can charge it. Yeah, maybe I should. All right, hold on. I am getting my iPad out. Wait, what happened? I apologize. I am not a professional YouTuber. The qualities of my videos are like, you hear background noises and everything. I'm so slow at moving screens around, but I thank you for your patience. Okay, so I got down here to my iPad. Okay. So these were the problems that we did before. Okay, so here, let me set the first derivative equal to 0. 4x cubed minus 12x squared equals 0. I am trying to find the critical values. I'm going to factor out 4x squared from both of them. I'll get x minus 3 equals 0. Because 4x cubed is the greatest common factor. Well, which means first critical value is where x equals 0. The second critical value is where x equals positive 3. So I found the critical values. We set the first derivative equal to 0 and found, Luna, stop. The other critical value is at positive 3. So I'll go ahead and enter that. Check answer. Okay. All right. What is true about f of x at this point, positive critical value? So what are they asking for? What's true about it? Oh, it looks like they want us to examine its concavity. Concave down, blah blah blah. And also to tell if it is a relative minimum or relative maximum. So what I will need to do is, well, I will need to plug in this positive 3 into the second derivative, okay? So take a look. The second derivative function is f double prime equals, you see what it is right there. So I'll plug in 3 into the second derivative, okay? That is 12 times 3 squared minus 24 times 3, which is I typed it in right here. 12 times 3 squared minus 24 times 3, and that got me positive 36. We don't really care about the numerical value. What we care is that that 36 came out to be positive. So because the second derivative is positive, what we know is that this 3, comma something blah, I don't know what the y-coordinate is yet because I never found it. But what we know is that because the second derivative is positive, this must be a relative minimum by the second derivative test. Well, positive second derivative means this is also concave up at this point. And what does concave up look like? Maybe I should have done that first because you guys like picture better, don't you? I like the picture better. This is what concave up looks like. So that's why this point is going to be relative minimum. So we found it all. This is going to be concave up and it's going to be relative minimum. Do they want the y value? I don't know yet. Let's see what they want. I'm going to click on concave up and tell them this is a relative minimum and the x value is 3. Now they want the y value. So let's plug in 3 into the original function. Okay, the function was f of x equals x to the 4th power minus 4x to the 3rd power. So if I plug in 3 to find its y value, I will have to evaluate that. So what's that? When I type that in into this scientific calculator, I got negative 27. So that must be, and this time I actually care about the numerical value because this is the y coordinate of this relative minimum. So let me go back to my math lab and then I will type in negative 27. I got so many tabs open, I don't know where my homework is. Oh, here it is. I'm going to type in negative 27 as the y coordinate of this relative minimum. And then I'm going to click on check answer. Hooray! Okay. It says 5 parts remaining. Use the table feature of your grapher to answer the following. F of x has 2 inflection points. The second derivative, f double prime of 0, to find them. Okay, I will. So the second derivative we found already was right there. I don't know if you guys can see it. I'll write it big on my notepad, okay? F double prime of x is 12x squared minus 24x. To find these potential point of inflection, I must set this equal to 0. Let me factor out 12x from these two terms. Then I'll get x minus 2, which means x can be either 0 or x can be positive 2. So it has 2 potential point of inflection. So let me go and give them 0 and 2. Oh no, that's not what they wanted. All right, I better read this a little more carefully. They said one of these inflection points is at x equals 0. Oh yeah, we did find that, right? We do have x equals 0 and x equals 2. So what are we doing here? What is the slope of the curve at the inflection point 0, 0? So we want to find the slope of this tangent line. slope of the curve at the inflection point 0, 0. So what I will do is I will just plug in 0 into the second derivative, okay? If I plug in 0 into the second derivative, I'm sorry, not the second derivative, the first derivative, wouldn't that just be 0? Because if 0 goes in here and 0 goes in there, because slope of the tangent line is the first derivative. So that's why I'm using that first derivative. I'm just going to go ahead and type in 0 here. The slope of the curve at 0, 0 is 0. Where are they going with this? Okay, I'm done. I'm going to click on check answer. Okay. What is the x-coordinate of the other inflection point? Hey, I know what that is. We got that to be 3, wasn't it? Oh, no, that was 2. And that is from this right here. You see, we did that together. We found the other inflection point by setting the second derivative equal to 0. So I'll zoom out and I'll click on check answer again. Oh no, my laptop has 1% left. Let me pause the recording and then try to find the charger for this. Give me 1 second. Okay, so next question is asking, what is the slope of the curve at this inflection point? They want the slope, which means I now need to plug in this 2 into the first derivative. What was the first derivative? Go ahead and find that real quick so that I can plug it in. The first derivative was, or is, 4x cubed. Hold on, let me move my mouse so that I can see the symbol. Minus 12x squared. They want the slope, so I'm going to plug in that number 2 in here. What is f prime of 2? That is 4 times 2 cubed minus 12 times 2 squared. Let's type this into a scientific calculator. Take a look at the top line of my Desmos scientific calculator. I typed in that expression right there to evaluate the function. So 2 times 4 to the, sorry, that was wrong, to the third power minus 12 times 2 squared. And that came out to be negative 16. So that's the slope of the curve of the tangent line at this point. So let me type in negative 16 in my homework. The slope is negative 16, and let's check it. Excellent. All right, next, on which interval is f of x concave down? Use a table on your graphing calculator. I don't need that. We know how to do this without a graphing calculator. So let me go bring up my notepad and let's do the concavity work. Okay, let's do the sine work. I'll bring it over here. And maybe if you guys click on Help Me option on my lab, they will show you how you can do this using graphing calculator or the table on the calculator. I dropped my pencil. Let me go grab it real quick. Alrighty, we have 2 points of inflection, and I don't know if they are, but they said it is. Without really doing the sine work, I don't want to say that they are the point of inflection, but my lab said it is. It's okay. So, the smaller number was 0, and the bigger number is 2, so I set up my number line like this. Okay, it's alright. There you go. The second derivative, let me write it down over here. I can remember what it is. Let's see. The second derivative is f double prime equals 12x squared minus 24x. Hey, you know what? In fact, I have something better. I have this factored out, didn't we? We have this factored out somewhere. Here it is. Because if we are finding the sign, it's much easier to work with the factored form. 12x, I'll write it down instead of copying it. 12x times x minus 2. Why am I writing the second derivative? Because I am about to check the signs now. Okay, I will plug in a number that is smaller than 0 into the second derivative. If I plug in -1, I will get 12 times -1 times -1 minus 2. Guys, this is positive times positive 12 times -1 times -3, isn't it? If we multiply two negatives together, this will be positive. Positive means this is concave up. Okay? Because they said these are point of inflections, I know the middle section will be concave down. But I'm not gonna just believe what someone tells me. I will check it myself. What about f double prime of 1? 1 is in between 0 and 2. So if I plug in 1, I'll get 12 times 1 times 1 minus 2. Hey, this is 12 times positive 1 times -1. Because of that -1, this thing turns out to be a negative. So I get that the middle interval is concave down. So they were right about 0 being the point of inflection because the concavity did change to the left and right of that point 0. Now I need to do one more interval, which is 1 to the right of 3. How about I pick to the right of 2? I will plug in 3 into the second derivative. That's going to give me 12 times 3 times 3 minus 2, which is 12 times positive 3 times positive 1. If you multiply three positive numbers together, it comes out to be another positive number. Therefore, positive second derivative implies the interval to the right of 2 is concave up. So it is concave up on -infinity to 0 and 2 to positive infinity, and concave down in between 0 and 2. Let's go ahead and type this answer. Just gonna memorize that concave down in between 0 and 2. When I come over here, concave down on 0 to 2. This is taking longer than I expected. And concave up everywhere else. And if I am to graph it, I should look for a graph that looks like this fourth degree function. Now I'm using pre-calculus though. If I'm looking at this graph should be opening upward because the leading coefficient is positive. So I'm looking for a W-shaped function, not an M-shaped function. So which one of these is an M shape? Not A, not B, either C or D. So which one, I mean, the difference between C and D is that D goes down deeper. D is like going down all the way down there. So do we have a relative minimum? Did we find that value sometime? I don't know. I can't remember. It's been 18 minutes, guys. Oh, we did find the relative minimum is at 3, -27. So which one has a value at 3, -27, C or D? Let's see. Now look, D goes down to like close to -900. I don't think it's that because it goes down way too down, like too low. -900. No, my relative minimum was only at 3, -27. This looks more like it. I'm going to click on C. I remember I had to graph these functions by hand on my calculus exam. But, well, this problem, we couldn't really graph it. So we were just going with the closest one. So I am done with this problem number 11. That took me 20 minutes. So that was fun. I don't know. I'm kind of having fun doing these now. I may do another one today, but I will stop the recording for this problem here.